Hi, welcome to Data Structures and Algorithms series by Coding Ally. Coding Allies is a non-profit organization where we believe women and gender minorities should have a safe space and support system where they can foster their skills and careers in tech. I'm your host Sue. Today, we are solving this Leetcode problem 905 sort array by parity. This is the agenda. First, I will read through the problem statement, go through the thought process behind, and then walk through the two-pointer approach with JavaScript. So this is the problem statement. Given an integer array nums, move all the even integers at the beginning of the array, followed by all the odd integers. Return any array that satisfies this condition. So let's have a look at the example. In here, example 1, the input nums given is 3, 1, 2, 4. So from here, you can see that 2 and 4, they are even number, so they will come to the beginning of the array. In the explanation, here it's given that the output, it could be 4, 2, 3, 1, 2, 4, 1, 3, 4, 2, 1, 3. They are all acceptable. Let's have a look at example 2. In example 2, there is only one element, 0, so the output will be 0. The constraints given are nums length, the number length is inclusive between 1 and 5,000, and the value itself is between 0 and 5,000. So how can we solve this problem? There are many approaches that you could take to solve this problem, but in here I'm going to use the two-pointer approach. The first approach is two-pointer approach with extra space. That is the approach that I'm going to use in this video. I will make a separate video for approach 2 and 3. So approach 1. These are the steps. After these steps, I will go through the example with visualization. So step 1, initialize the result array of the same length. Step 2, we will initialize the pointer and start at index 0. Step 3, iterate through the given array. Divide the element by 2. If the remainder is 0, it is even. Then add the element to the result array and increment the pointer. So step 4 is exactly the same like step 3. And in this case, the remainder is 1, so it is an odd number. So in this case, it is odd, so we can add the element to the result array and keep moving the pointer. And then at the end of the loop, we can return the result. So these are the steps. So now let's have a look at the visualization part with the example. So we are using the two-pointer approach with the extra space. So two-pointer is pink, this pointer, and this green pointer. Extra space is the result array. It is created, and the length of this result array is same as this nums array. So let's walk through the pointer. At the beginning, both pointer are at index 0 for both nums array and result array. Now we check. Now in the first, so we have seen that there are two steps that we are going to go through. So I will go back. So we will iterate through the array given time 2 times. The first step is we will check for the even. That's in the second round. When we go through the array, it will be we are checking for the odd. So yeah. So first we check 3. 3 is obviously it's odd. So in this case, we will not increment this p pointer because it is odd. We will not increment this green pointer. We will only increment this pink pointer. So now at this element, index 1, element 0, it is again odd because how we know odd, we divide it by 2, we get the modulus. Modulus is, it will be 1. So okay, this is again, it's not even. So we will now again increment this pink pointer. Okay, now we are at this index 2 and we can see that the value is 2. It is even with the modulus. The remainder will be 0. So now it is even. because it is even, so we can put the element into the result. So after we push the element, add the element into the result, we can increment the pointer, pink pointer, as well as the green pointer. Now we check again. 4, we modulus the divide by 2, and then the remainder is 0, so it is even, and then we will add this element into the result. So by the end of one round, we will finish checking for all the even elements. Next, so this is the step 4. In this step, we iterate through this exactly the same array, nums array. In this case, we are checking for the odd element, and we are adding all the odd element into the result array. So first we check so current pointer for P is currently pointing to index 2, and then for P, this pink is at the beginning of the array 3. We check it is odd, so we can add this element into the result. Again, P, this pointer is at the pointing to index 3, and previously it is vacant. Now we check for the element 1. The remainder will be 1, so it is odd element, so we will add the element into this result array, and then we will keep going through, and then by the end we will get this result array, and we can simply return the result. So now let's have a look at the code. So this is step 1. We are initializing the extra result array with the same length of the num store length. Step 2, we initialize the pointer. So this pointer P is like a green pointer from the visualization. So initialize the pointer, index at 0. So this step is step 3. In this step, we have to iterate through this entire array. In here, we are checking, we want to first add the even element into the result array. So that's what we are checking. So starting from, so I pointer, because I don't want to use like P1 and P2, pointer 1 and pointer 2, I is commonly used. So in here, I, it represents the pointer pink in the visualization part in here. So now we will iterate through this entire array, and in here, in this if condition, we check nums at this index, we check for the remainder. If the remainder is strict equality, if it is 0, then we will, only if the case, we will add that result into the result array, and then we will increment the pointer for the green pointer, which is P. So by the end of this round, we should have all the even elements added into the result array, and the pointer should be, this pointer P should be at the index where we can start for checking for the odd elements. So this is for the step 3. Now we can go for step 4. In step 4 is exactly the same. We go through the entire array like in this step, but in here the condition is we are not checking for the even elements, we are checking for the odd elements. If it is the odd elements, we will add this element num set I into P, and then we will increment this P pointer. So by the end of this loop, we will get the result array which contains the elements that are sorted. So let's discuss about time and space complexity. So first, let's start with this line. This is the space, additional space. We have created the additional result array which has got the same length as num. So the space complexity is O of n. The next is time complexity. For time complexity, if we look at this block of code, we are going through every single element till the end of this num stop length array. So therefore, this is O of n. Exactly the same for this block of code for checking for the odd elements. So for that, O of n. So combine these two, O of n plus O of n, O of 2n. But overall will be O of n. And we can return the result. So this is the time and space complexity. In here, you can see that this we have used the additional extra space. We have also iterated the nums array 2 times. If the nums array length is 5,000, we will be iterating through 2 times, so it will be 10,000 that we have to iterate. So in here, you can see that they are optimized in terms of space, in terms of times, we can optimize. So for that, for that optimized approach, we will be looking in the next video. So in terms of learning summary for this approach, we have learned about 2-pointer approach. We learned how to initialize the pointer location. In this approach, we use both start and start. Both pointers they are at the start location, which is 0. And we how to move the pointers, and we move forward because they are both at the start. And then we have added the stop condition, and we also discussed about the time and space complexity. So thanks for watching. Please make sure to subscribe and press the like button if you find this video useful. Join our weekly Wednesday Data Structure and Algorithms Night, where we organize peer-to-peer coding interviews. You can find event details on our Facebook page. Thank you.